All right, this will be a relatively quick one. So this isn't part of the main domains of tabular problems, but these particular types of problems that you're about to work on are common enough to kind of get their own little subpath in the wildcard section of these FRQs. So these types of tabular problems are mean value theorem problems, is what they are. So what you'll be doing is solving some mean value theorem problems relating to tables or possibly graphs or other pieces of information and writing up a couple sentences of explanation, either why something must be true according to the mean value theorem or the intermediate value theorem or something like that. So before we jump into this next part, which is part B, what I would recommend you do is take a little bit of time to Google or look in your notes for what the mean value theorem is and find it. So why don't you pause the video and do that, and then we will come back. Okay, so if you've done that, you should probably have seen that the mean value theorem says that for a function that is both differentiable and continuous, then there must be a point, C, such that f prime of c, or the instantaneous rate of change, sometimes we call that the IROC, the instantaneous rate of change, is equal to the average rate of change, which the formula for the average rate of change is f of b minus f of a over b minus a. So let's take a look at how this applies to our problem in part B. So this is the coffee cup problem, the coffee maker problem with hot water dripping through it. We've got a certain amount of ounces, and then at each particular minute t. So what part B is asking is there a time t, for t from 2 to 4, so is there a time t within this particular time interval at which c prime of t, that's the instantaneous rate of change of the amount of ounces in the cup, is equal to 2, and to justify our answer. So first off, you need to recognize that this is a mean value theorem problem. And two of the ways to recognize a mean value theorem problem is the interval that they give you, from, in this case, from 2 to 4, and also the statement about the instantaneous rate of change, that c prime is equal to 2, or that f prime is equal to 6, or that h prime is equal to 3.5, just something like that. So what we want to do here is to investigate the average rate of change. And what we're going to do is take a look at the interval that they've given us from 2 to 4, and let's find the average rate of change of c over that interval. So I would be finding c of 4 minus c of 2 divided by 4 minus 2. And if I look up in the table, I see that c of 4 is 12.8. And, whoops, excuse me, not c of 3. c of 2 is 8.8. So we end up with 4 over 2, which is 2. This is the average rate of change. The units on this are ounces per minute. And what we can do here is we can reason that because it says that C is differentiable, we can start writing and say, because C is differentiable, and because C is differentiable, it is therefore continuous. So because C is differentiable and continuous, and the average rate of change of C on the interval to 4 is 2 ounces per minute, we say by the mean value theorem, C prime of t must equal 2 at some point in the interval 2 to 4. Most of the other mean value theorem problems adhere to this particular way of communicating, way of writing. So what I want you to do is just get comfortable talking like this. You're looking to say that your function is differentiable and also continuous. You're looking to demonstrate that you know that the average rate of change is whatever number you need it to be. And then you make the conclusion by the mean value theorem, the instantaneous rate of change has to be equal to that number on that same interval. So there has to be some t value within here where the amount of water in the coffee cup is filling up at this rate of change in the time interval 2 to 4. Okay, go ahead and give those a shot, and remember to check your answers. If you got any questions, let me know.